Good afternoon, everybody. So my research in here, a review on graphical symbols identification of food packages by using machine learning. So this is my overview in this presentation. As the introduction, actually we know there are more than 7,000 different languages are spoken worldwide. But if we want to pass some message for anyone, someone cannot understand if we pass it with some language. But how about the symbol? That's why it is tend to develop these graphical symbols as visual perceptible figures. So there are so many different kind of symbols we can see in daily general consumer symbols, scientific and engineering symbols, hazard symbols, like so on. So, but the problem is we don't have much awareness about those symbols and no convenient way to learn these symbols. When we consider about the graphical symbols on food packages, actually most consumers are consider about only expiry dates like that. But lots of side effects like gene problems and other cancers like that are causes for those kind of bad habits, food consuming habits. If we if we aware about those graphical symbols on food packages, food labels, I think it's a good way to avoid those unnecessary side effects. So that's why I'm propose this solution. So this research work aim is to narrow this research gap of difficulty to identify symbols on food packages and develop a convenient approach to identify about graphical symbols. So this research problem actually there are strict standards to provide proper information on product packages with standard symbols. So, like ingredients, nutritional information, dietary restrictions, allergen warnings, package materials, as well as disposal methods. So there are a lot of messages with these symbols. But the problem, I conducted some Google form survey. This survey for identify some symbols. This is the actually median average correct answers out of 28 symbols. It was 12, less than half marks as well. That's where our knowledge. There was a different kind of age background people, and were both male and female. But our knowledge and our awareness about these symbols are really low. So. When I review those in this review process, actually I didn't found exactly similar graphical symbols, food items graphical symbols, identification research works with machine learning and image processing. So I saw some overall methodology as a summary, as the average methodology, because all of those review papers, all of those image researchers have collected image data set with the image filtering as a basic stage, then the extract features, then those extract features are input to the classifiers by using machine learning techniques, and then these trained models have developed into the deployment level. So here in this paper I reviewed 12 research works. So as in here, basically I considered about image processing, filtering techniques, image pre-processing techniques, and feature extraction techniques, and also symbol classification methods. And also when we consider about image pre-processing techniques, we can see in all of those research works, morphological operations and binarization, medium filtering, and like those kind of pre-processing techniques have used in this usually used in these graphical symbol identifications. So this aim is to remove the noises and diminishing the false points of images. So image thresholding, smoothing, sharpening, and using filters, we can use we can do this operation. And also then when we are moving to the feature extraction methods. Actually, the main popular method is scale invariant feature transformation. Actually, there are 4 computational stages in there, and detecting distinguished invariant image features that provide vigorous matching between different views of an image, and scale space extreme detection point scale space extreme detection and key point localization, orientation computation, and key point descriptor are 4 main stages on this scale invariant feature transformation. But the problem is actually this feature extraction technique a little bit slow and inefficient. So we can see speed up robust features extraction technique. We can introduce this technique in order to instead of the SIFT feature extraction technique. It is kind of an extended version of SIFT, and it also it requires fewer operations. It requires integral images because it requires fewer operations and efficient processes. So there are 2 stages are called key point detection and key point description. So SURF is more efficient descriptor do this feature extraction technique. In addition, here I repeat some histogram of oriented gradient system, also somewhat popular feature extraction technique for this. And when we consider about classifications, the most popular one is support vector machine and artificial neural networks. When we consider about artificial neural networks, actually we know it is really when we consider about artificial neural networks, we know artificial neural networks model is really similar to human nervous system. So we can actually, as human, we can learn things by experience. So in here, artificial neural networks, usually we prepare a data set to learn, and it is we taken it as a supervised learning method. So it is really, and also artificial neural network is it is a non-parametric classifier, and it is an universal functional approximator with arbitrary accuracy, and also it is capable to present functions such as or and not, or and not. And also it is a data-driven self-adaptive technique and efficiently handle noisy inputs as well. So I thought, according to this review, there are high accuracy levels also can be achieved with those artificial neural network model as well. So, according to this review, finally I propose my solution with the artificial neural network, and also by using as a feature extraction technique, SURF method for the proposed solution. So that is it for this research work. Thank you for all of you.
Thank you very much for your interesting presentation. Any questions? Any questions? Okay, I'll ask one question from you. You were talking about this food recognition, right? So you have mentioned several alien-based techniques. So, and what do you recommend? Which one to be chosen?
You mean machine learning techniques?
Yes.
Yeah, I recommend artificial neural network because it is more convenient and it can identify more noise inputs as well rather than support vector machine like that. Because support vector machine technique, this kind of result is not transparent, result accuracy than artificial neural network, and it is easy to we take extracted features to take artificial neural network with more accuracy level.
So alien might need a lot of data and a lot of time to learn the model. So accuracy wise it's high, but the other, there's a trade-off between the learning methods, right? Any other questions? Yes. Yes. Yeah.